Hey, what's up everyone? Welcome to this new chapter of my SwiftUI training course. This time we are going to focus on a new topic that I've called advanced data flows. So last time, if you remember, in the last chapter, in the previous chapter, we focused on navigation, how to transition from one view to another. And today we're going to go back to what is kind of the sequel of what we saw in the chapter state management, because we're going to talk about other kinds of data flow. What have we seen up until now when it comes to data flow? We've seen what we could call either direct or explicit data flows, where we would store data into some properties that were annotated with special property wrappers. I'm thinking, for instance, of things like @state, @binding, @observed object, these kind of things. We saw that this mechanism allowed us to implement parent-children data flows, so two-way data flow, but there was one common characteristic to all of these data flow, is that they were what we could call explicit, in the sense that data had to be explicitly passed through the initializer of the child view. So we saw it when we passed some data to display to a child view, or when we passed a binding to a child view. And in this chapter, we're going to see other kind of data flows that are implicit data flows, meaning that they will allow two views that don't know each other to communicate. And with these mechanisms, we'll be able to both send the data downwards in the view hierarchy, but also to have data flowing upwards from children view to parent view. And you'll see that the mechanism I will show you, we've actually seen them sometimes entirely, sometimes just a glimpse of them in the previous chapters, because for the downward data flow, we will talk about the environment, which we saw a little bit at the end of the previous chapter. And for the upward data flow, we'll see how preference keys work. And we haven't seen preference keys directly, but we saw a modifier that actually used them, and we saw actually more than one, but one that I highlighted was the modifier navigation title that allowed us to set a navigation title on a child view and then have this data be picked up somehow by the parent navigation view. This was implemented by a preference key under the hood. So this is what we're going to focus on today. As you can see in the code behind me, I have a starter project that we will begin with. This project is available on GitHub. You have the link in the description of the video to download it. And before we start, two last things I have to tell you. If you're watching live on YouTube, remember that one of the big advantages of the live is that you can ask questions and make remarks in the chat. And when you do that, not only can I answer you or try to answer you as best as I can, but you also probably phrase a question or a remark that the people watching the replay will also have, and so by voicing it, you make it much easier for them, for the people watching the replay, to get that answer. So thank you in advance for your participation during this live. And last thing, if you want to download all the videos, or if you just enjoy this training course and you want to leave me a tip, the videos and the Excel projects are available for sale on Gumroad. So the link is also in the description. You don't get anything more than on YouTube, except that you can download everything with just one button. And all of that being said, I think it's time for us to get started. So let's see this project I have created. So the project called Starting Point in the code project, in the Xcode projects. I'm going to launch the app in the simulator. You will see it's nothing fancy. I made a very simple app. Let me show it like that. So you can see I've put in a tab view 3 views. So one view for the feature number 1, one view for the feature number 2, and one view for the feature number 3. Very simple app. If we take a look at first view, at first feature, second feature, and third feature, you can see that they are basically empty views. It's just the hello world view, except that I have changed the text to be something else. But by having this small structure, we have everything we need to be able to start and implement some data flow between parent views, child views, and parent views. As always, I have a script next to me to make sure I don't forget to tell you anything. So let me check what I want to show you first. So first, I want to show you an example of an implicit downward data flow. And for that, I'm going to take the example of implementing analytics. Let's imagine I want to implement some analytics, so I want to have a way in each of my three views to be able to send an analytics hit whenever the view is opened, whenever the view is displayed on screen. So it's a very common use case. As soon as you start implementing analytics in an iOS app, you basically need to say that, okay, this screen was indeed displayed to the user. So how can we do that? First thing, we need to have a way to implement these analytics. So let's implement an object for that. So I'm creating a new Swift file and I'm going to call it analytics, like that. I'm gonna make it a class and I'm going to do something very simple, just declare one method that will be, okay, I want to send a tag to my analytics backend. The tag is going to be a string. This way it's very simple. And of course, we're just going to mock this by printing to the console. And so I will say tag, the tag that was given as an argument was sent. All right, we have our analytics. Now the question is, how do we make it available to our three feature views? If we use the techniques we've seen up until now, what we would do would be, we would take, for instance, the first feature view. We would create an initializer that would take the analytics as an argument, like that. We would store it somewhere. So we would have our property, so var analytics like that. We would store it. Okay. For now, analytics is not an observable object, so we don't need to do anything special. And here, in the onAppear of my view, so like that, in the closure, I would do analytics.send tag, and the tag would be feature 1. Something like that. Okay, yes, I forgot to assign it. Of course, I need to provide my analytics right here, so I would probably store my analytics here at this place, so at the top level of my app. It would be something like that, so as a constant, and then I would pass it through the init. Right? Build failed because I put it on the second feature and not the first, I think. No. Yeah, I put it on the first feature. So why does it say? Oh, it's here. Yeah, and here we need to provide also something. And I'm just going to create one on the fly. All right. And so now, if we look at the console, we can see that indeed, when we display the first feature, the analytics is sent. So the data flow I've implemented works. It's perfectly correct, but it has one drawback, is that for each of these objects that the view needs to know, we need to add one more argument to the initializer. And as you can imagine, this won't scale very well because the number of arguments is going to increase every time there is something new. And also, all the views will need to keep passing to their children all of these objects. Because here, my view needs to know the analytics, but if it has a child view, it will need to also pass it to the child view, because even if the child view doesn't need to use it, maybe one of its own child views will need it, and so you end up having to add a whole lot of arguments to your initializers all the way in your view hierarchy, and as you can imagine, this doesn't scale very well. And so this is where the environment is going to come into play, because the environment is going to allow us to inject this analytics instance only once, and then all of the views in the view hierarchy will be able to retrieve it from the environment when they actually need to use it. And so views that won't need to use the analytics will just be able to ignore it. They won't have to do anything special about it. I see a question, can you add subtitle in this video? So there will be subtitles on the replay. For the live, I think there are automated subtitles on YouTube, but I can't do anything better during the live, unfortunately. So let me see if I haven't forgotten anything. No, I've told you everything I wanted to tell you. So let's see, how do we use this environment? So let's go back to our app, because this is where we're going to do the injection. We want to do the injection at the topmost level possible, and here sounds like a good place to do it. So to inject an object in the environment, you call the modifier environment object, which has a name that makes it fairly discoverable, and we can see it allows us to supply an observable object to a view hierarchy. So you can notice that the object must conform to the protocol observable object, which is not the case for now. So just need to make it conform to observable object. And with that done, now I can inject my instance of analytics in my environment, in the environment of my view hierarchy. So the view hierarchy defined by my tab view right here. The injection has been done, and now what I can do is get rid of my initializer. I don't need it anymore. I'm still going to keep my property, because my view still need a way to refer to an instance of analytics, and to retrieve the instance from the environment, I will annotate my property with yet another property wrapper, this one being called at environment object. I'm going to remove my the init, the argument of the init in my preview, and we'll start launching the app again, and we'll see what's going to happen. So here I need to also remove the argument in the initializer. All right, now it should work, and you can see that it does work as expected. We can see in the console that the method is indeed called on the instance every time onAppHere is called on first feature view. So the environment for this instance worked. You can see that it was fairly easy to put it together. That's one of the big advantages of this mechanism, is that you just need to inject the environment object at the top of your view hierarchy, and then all the views in your view hierarchy can retrieve it. And so here my view first feature view was able to retrieve the analytics from the environment and use it, and my two other views, they didn't want to use it, and so they were able to completely ignore it, even though the instance of analytics is still available in the environment for these two other views. But they could totally ignore it, and if one of their child views wants to use it, it will be able to, without the need of an explicit data flow between the parent and the child view. Of course, as with many things in computer science, simplicity comes at a price, because we are going to see that if I start my preview, something should go wrong. So let's see what's going to happen. In the meantime, you can start thinking about what is going on. So we have a crash. Let's see if I can get an error message somewhere. So what's kind of annoying is that it appears and then disappears so fast, but it was saying analytics is missing from the environment. Yeah, unfortunately, I cannot get a better error message. So that's kind of one of the drawbacks of the previews, that when they don't work, it can be a bit hard to know why they didn't work. But what's interesting to see is that here we are creating our first feature view right here in the preview. So there is nothing else in the view hierarchy. So the injection we make here in the tab view has absolutely no impact on the preview right here. Exactly. So Vlad, you've said it, the preview has no environment object injected. And it's really important to see this crash in action quite early, because it allows you to really understand the fact that the apparent simplicity of @environment object comes at the price of @environment object being basically a glorified force unwrap. What's happening is that you can see the environment as a big dictionary for which the key is the type of the instance. And when you are doing @environment object, you are querying, you are subscripting that dictionary with the key, which is a type, and you are force unwrapping the result of this subscript. So if there is nothing in the dictionary, you are basically having a crash. So I can fix this in my preview by injecting an instance of analytics in the environment. It fixes it, as you can see, but it shows that this mechanism, while being very easy to put into place, you want to be very careful about it, because if you forget to correctly inject something in the environment, your app will crash. And of course, when it's in one of the first views of your app, it's relatively easy to see it. But if it happens in a view that is more nested in your navigation flow, it can actually be quite hard to notice it. So when you use @environment object, you probably want to use at the same time some testing techniques to make sure that indeed when you navigate on every screen of your app, there is no crash because dependency failed to be injected by a parent view. And I can tell you from experience, it can happen a bit more easily than what you think when you start using it. So let me see what else I wanted to show you about this. So there is actually another way to inject and retrieve values from the environment, because remember last time we didn't use @environment object, we just used @environment and we provided a key path to it. So we saw that there were some key paths that were already defined by SwiftUI. Last time we used the dismiss key path to get the action that allows us to dismiss a view. But we can also create our own analytics keys, and that's what we're going to do right now to inject the analytics through that custom key, and we'll see what are the advantages and the drawbacks of doing things that way. So I'm going to create a new Swift file that I will call environment like that keys. And inside of it, I will create a new environment key. So basically a new key path that I can pass to the property wrapper @environment. So first thing is to create a struct. I will call it analytics environment. I'm trying to not make a typo when I write this. So like that. Key, all right, analytics environment key. And I need to make that struct conform to a protocol that's called environment key. Let's see what's inside this protocol. What are the requirements? So jump to navigation isn't working. Let's try to do it that way. So it's a protocol that's fairly simple. We need to provide a default value. And as you can imagine, this is what will make this approach a little bit safer than using @environment object. With environment object, we didn't have a default value, and that's why there was a crash when nothing was injected. Here we do have a default value, which is going to allow us to not crash when a value hasn't been injected. So let's implement this default value. You can notice that this default value is static because it will be called on the type itself. So default value, it will be an instance of analytics, and I just create my instance. So this means that if I don't inject anything else, this is what will be retrieved when we query the key path analytics. Environment key is part of SwiftUI, so I need to import SwiftUI in this file. All right, now it builds. So I have my environment key, but that's not enough because we still need to define the property whose key path we will be using with the property wrapper at environment. And for that, we define an extension on this type called environment values. And on it, we create a new property that will be a computed property. We call it analytics, so that's the name of the key path we'll be using. We give it a type, which is what we will retrieve or inject. So here it's analytics. And then we implement both the getter and the setter because it's a computed property. And how do we retrieve an analytics from the environment? This looks a bit weird, but we're going to subscript self, and that's because in environment values, self can be subscripted. We can see it as kind of a dictionary. We use our key, and we use the type of our key to do this subscripting. And for the setter, what we do is that we simply use the same subscripting mechanism with the same key, and we set the new value. Let's see if this builds. This does build. We can see that I can actually make the struct analytics environment key private because we won't be using it. Only SwiftUI through the extension to environment values needs to know about it, but we will only use this property to interact with the environment. And so now in my view, first feature view, let me show it like that so we can see both things side by side. I feel like it will make it much easier to understand. I'm going to remove at environment object, and instead I'm just going to use at environment and pass in the key path for my analytics property. And so this key path right here corresponds to this property right there, and it allows us to read and write from the value that's available to the view through the environment. And this time we don't run the risk of not having provided a value because we have this default value right here. So I can actually get rid of the modifier environment object. I can get rid of the injection here also. Actually, I don't even need to store my analytics at the app level because it is already being stored in my environment key right here, and it's stored in a staticlet. So it's kind of like a shared value when you think about it, kind of like a shared instance, except that, as we're going to see, we can also overwrite it locally. But for now, let's make sure that everything works as expected. So I'm going to launch the app in the simulator first. We can see it works as expected on the simulator. All right. When I switch features, we can see that it gets updated just like we want it to do. Sorry, I'm struggling to make a window appear at the right place. That's perfect. Okay. And then let's see also in the preview. Of course, I killed the simulator. Let's go into the preview. I'm going to resume it. You can see the preview is also working because it is also using the default value in my preview. So that's pretty nice. However, there is one big difference that is very important to notice. It's that, remember when we used environment object, I had to make my view, to make my analytics instance and my analytics class even conform to observable object. If I remove this conformance, you can see that my app still builds. I'm going to relaunch it. You will see that it is still working perfectly fine. So we no longer have this requirement of having the values we inject conform to observable objects. But it comes with a drawback, and it's that should our object be an observable object and should it have some published properties, if we set new values into these published properties, it wouldn't trigger an update of the view when we get the value through the environment value like this. So when it says environment values, the word value is very important because it is value in the sense of a value type, meaning that when the value changes for a struct, you will get the view being updated. So for instance, if you inject an int or a string and that int or that string changes, the view will be updated. However, if you inject an observable object through an environment value, then your view won't be updated when this observable object publishes a new state to its published properties. So it's a big gotcha, honestly, because it's very, very easy to make that mistake to think, okay, environment values seems like a much safer approach, so I will always use it. Unfortunately, it's not always the right tool. When you want to inject an observable object, you really need to use @environment object. Unfortunately, there is no other approach, and so there is no other way to guard against the potential crash that environment object can create, other than writing tests that make sure that you can navigate in all the views of your app without crashing. So what should you remember from what we've seen up until now is that when you want to implement an implicit data flow between a parent view and a child view, the tool for that in SwiftUI is called the environment. And there are two ways to use the environment in SwiftUI. First, you can use @environment object, no, that one, along with the modifier environment object. This allows you to inject instances of observable objects through the environment and to retrieve them. It's super easy to put into place, but with one drawback is that if you've forgotten to inject something, then you will get a crash. But the big advantage is that when you inject an observable object through this mechanism, you will get your view updated when this observable object publishes new state to its @published properties. And on the other hand, you have another mechanism to inject values into the environment. So using environment values, so this type right here. And for that, you create an environment key, which allows you to produce a default value. And then you extend environment values. You define a new complete property through which you will read and write from the environment using this key that you've just defined. And this mechanism is safer because it comes with a built-in default value, but it doesn't really work for observable objects because if you inject an observable object through this mechanism, then updates to its @published properties will not be taken into account. So as a rule of thumb, whenever you have something that is @observable object, inject it using environment object. Otherwise, you just run the risk of having a bug. But when you need to inject anything else, I would say it's much better to use environment values because it is a safer approach. And what's nice with the environment is that you can also override it locally. So for instance, I'm going to create a mock analytics. It's going to be a subclass of my analytics class. So like that. Inside of it, I'm going to override the property send data. And I'm just going to print that we are in the overridden method. So just to make sure that it has worked or not. And what's pretty cool is that it's possible to actually override the environment. So here I can inject a new value for the key analytics. I will inject a mock analytics, and what's gonna happen is that now only first feature view will have this mock analytics in its environment, but the rest of the views will still have the default value, which is just an instance of analytics. And to see, to test whether it worked, I'm going to replicate my mechanism of printing something, or rather calling the method sendTag through the onAppear modifier. So feature 2, like that. And I will launch my app in the simulator. And you can see that for the feature number 1, it calls the overridden method. But for feature number 2, it calls the regular method of the regular analytics. And so let me also display, yes, like that, so that I can display everything on the screen. Okay, so something like that. And you can see, for first feature view, we have injected in the environment a new value for the key analytics. And so first feature view, when it reads from the environment using the key /.analytics, it gets this mock analytics. And so that's why it calls the overridden method in the subclass. However, for second feature view, we haven't injected anything in particular for this value analytics in the environment, and so it gets the default value, which is the regular instance of analytics. And when once you see that, you see all of the power of the environment is that not only can you inject values and instances that will be available throughout your view hierarchy, but you can also override them at some point in the view hierarchy. And when you have that, you have something that is quite powerful, because you can provide a value at the top level and then come and just override this at a lower level in the view hierarchy for a more specific need. And actually, we've seen quite a few examples of this behavior, because there are a lot of properties of modifiers we've been calling on views to configure them, that actually under the hood use the environment to transmit the information to their child views. And one interesting thing that we can note is that here on my analytics I have implemented both a getter and a setter, but it's actually possible to only make it a get, so a read-only computed property. And if I do that, I will get a compilation error, because so it's right here that there is an error, because I tried to write something in the environment for this key, but it's not possible because I've made my key read-only. So it's not something that you use every day, but it's good to know that if there are some instances where you really just want to make this value available through the view hierarchy and not allow any view to be able to override it, you can just not provide a setter, and not providing a setter will do the trick of making the environment value read-only. What's also interesting is that this is, in a way, if you did a lot of UIKit, you know that UIKit, especially at its beginning, used to rely a lot on shared instances. And shared instances, they have one big advantage, is that they are very easy to access. But one big drawback is that they make your code and your architecture very rigid, because it's quite hard to inject a mocked version of your a mocked version of a shared instance for a test, for instance. And here with the environment, we have kind of a nice way to solve this, because we can imagine that most of the time we could provide, for instance, a shared instance through the environment, and our views would only read that value and never write something to it. But if we want to write some specific test or have a preview, have a specific behavior, we could inject another instance, a different instance than the shared instance that would be pre-configured with some specific state, and we could inject it only in that test or in this preview. So in a way, I kind of see this mechanism as an improvement on the shared instance mechanism that used to be very ubiquitous in UIKit. Let me see if there is something else I wanted to show you. So we talked about the difference between @environment object and @environment. I think for the implicit downward data flow, this is all that I wanted to show you. Oh no, there is one thing that I have forgotten, and it's one pitfall that I want you to avoid. So let's imagine that we know about the environment. We know that the environment is really great. Like, we can retrieve a lot of things from it. So let me import SwiftUI. You can see it's a bit weird. I'm importing SwiftUI in my analytics. This is a sign that what I'm doing is kind of a mistake, but I want to show it to you so that you don't make that mistake. And we've seen that we can retrieve some cool things, like, for instance, the fact that whether or not the accessibility is enabled, which is a Boolean. And we might be thinking, oh, this is pretty cool, because now in the init of our analytics, well, we could also print something to say whether or not the accessibility has been enabled by the user. So it's not perfect, because if the user changes the setting while the app is open, we don't send a new analytics hit. But for first implementation, we could be thinking, okay, this is pretty cool. We are able to retrieve the environment from our analytics. And what I want to show you here is that if you try to build this code, it's going to build perfectly. But if you run it, you see, we immediately get a runtime warning saying accessing the Boolean from the environment outside of being installed on a view. This will always read the default value and will not update. And it's a pitfall I wanted to show you. And that pitfall is that you can use @environment basically anywhere. But just like we had seen that using @state outside of a view will not trigger any update of the UI, here it's the same thing. Using @environment outside of a view will actually never read the actual value that's in the environment. It will just read the default value. So here we are actually just getting a default value of false, and we will never actually get the value we want to have. However, it's quite easy to get tricked into thinking that this does work. And Xcode added this warning fairly recently, because I seem to remember that earlier we didn't have this warning. It's a good thing that they added it, because as we've seen, there is nothing at build time that lets you know that this is not a good idea. And in a way, it's kind of normal, because I don't think there is a way in Swift to restrict the use of a property wrapper to be only in specific types. But it's very important to understand that the environment is really tightly coupled to a view. Views have access to their environment, but outside of a view, you don't have access to the environment. And so if you ever get the idea of accessing the environment from inside a view model, for instance, I wanted to show you that it wouldn't work. And a telltale sign of it was that when you try to import SwiftUI in your business logic, usually it's a sign that you're trying to do something that you shouldn't be doing, because you're trying to use SwiftUI in a place where it's not supposed to be used. So with that, we've covered, let me get rid of the init also. So with that, we've covered downward implicit data flow. So how to pass data from a parent view to a child view without it being explicit, meaning without doing it through the initializers of the views. We've seen that this mechanism is actually quite simple. It's what I kind of like with this chapter, is that it's called advanced data flows, but when you start to see the content, you're like, okay, this is pretty simple. Brace yourself, the second part will be a bit more complex, but this first part about the environment is actually quite easy and quite straightforward. And personally, I think it's one of the really cool features of SwiftUI. So what to remember, when you want to pass data implicitly between parent view and child view, you use the environment, and you have two options. If you're trying to pass an instance of an observable object, then you use at environment object to retrieve the value, and the modifier environment object to inject the value. And the link, so the link to know how to retrieve the value, will be done through the type of the value. But be careful, because if you forget to inject a value, there will be a crash, because this is basically a force and wrap under the hood. And on the other hand, when you want to inject a value, you can do it by using an environment value, and this time you have to create an environment key and extend environment values. But this mechanism has the advantage of forcing you to provide a default value. This way, you don't run the risk of forgetting to inject something. Also, most of the time, when you want to inject a value, there will actually be a default value that will make sense, and it will happen quite often that you won't need to inject a value at the top level of your app, because the default value will just be the sensible value to have as a default. And one last thing I want to show before we move on to the second part is that when we worked on the navigation, we saw that you could retrieve functions from the environment. You could retrieve the function that allows you to dismiss view. So yeah, it's iOS 15 and my project is set to iOS 14. Let me update it. All right. We saw that we could retrieve functions from the environment, and I wanted to highlight it because it's actually quite an interesting pattern, quite a powerful pattern to be able to inject a function that will perform one job through the environment. So it can be a function to call when the user has executed an action. For instance, when the user has selected something. It's quite a powerful pattern that I've used quite a lot, especially when you want to integrate SwiftUI into a UIKit view hierarchy. We'll see how to do it in the next chapter. But when you want to pass an action that will interact with the UIKit world through to a SwiftUI view, encapsulating that action into a closure and passing it through the environment is quite a nice and elegant way to do it. Let me remove this because this actually doesn't make sense in the context of this simple app. Okay, we have seen the first part of this chapter, which was the environment for downward data flows. Now let's move on to upward data flow. So how do you pass data from a child view to a parent view without passing a binding through an initializer? To show you this mechanism called preference keys, I'm going to create a new view. So I'm going to call it login view. All right. I wanted to create a SwiftUI view actually, so let me remove the file and instead just create a SwiftUI view like that. Okay. I'm going to also add it right here. So I'm going to add my login view so that I can also access it from the simulator if I need it. And for the tab item, I'm going to copy paste from the finished project. Okay, so we have our login view. And before I show you the complex example, I want to show you a more simple one. Let me see what we could do. Yes, I know what I'm going to show you. So I'm going to create a navigation view like that. Inside, I'm just going to have a text that will, for now, just say login view like this. I'm going to display the preview. All right. And now, remember this modifier navigation title. You can see that I'm calling it on a child view, but the value I set on the child view is somehow consumed by the parent view, by the navigation view. So what we're going to do is that we're going to try and basically implement the same mechanism. So we're going to try and re-implement this mechanism of passing data from a child view to a parent view without the two views really knowing each other, in the sense that they won't be sharing a known mechanism to pass the data like a binding would have been. So I'm looking a bit at the finished project to see how I'm going to make it work, because I don't have this part in my finished project. I'm going a bit off script, but I feel like this I feel like it could be nice to show it to you like that. So what I'm gonna do, I can see I made a typo here. Let me fix it. Okay, I'm going to create a couple of views. So first one, I'm going to call it parent view, and the second one, I'm going to call it child view. I created a Swift file and not a SwiftUI view. Let me fix that. Okay, so we have our child view. Here, this one will just say child view. All right. And this one, for now, will just say parent view. Okay. And what I'm going to do actually, now I'm going to put a text. I'm going to put a text field. Yeah. A text field. So here I'm going to say just write something. I need to store that into a text. So something like that. I can actually do just that. Okay, and I'm going to embed this into a form so that it looks slightly better. All right, so why am I doing that? Because I want to remind you of the fact that here, between the text field, which is the child view, which is the grandchild view, and the child view, which is the parent view relative to the text field, I have an explicit two-way data flow through a binding. And what I will want is the text I write in the child view to actually be displayed in the parent view. So in my parent view, I will have a vstack, something like that. Okay, and then I will have the child view right here. All right, it's not super good looking, but it does the job. And the parent view will say, this is what my child asked me to say, and then we will put what was written into the text field. And so the question is, how do we do this data flow between the child view and the parent view without going through a binding? So this is where a preference key is going to come into play. So the name preference key is a bit like, honestly, I feel like it's not a bit of a misnomer, but the name is not super intuitive, because when you hear preference key, in an iOS context, you kind of think about something like user defaults, for instance, a way to store data, a way to persistently store data across app launches. And as it turns out, in SwiftUI, preference keys have nothing to do. I think the naming is supposed to convey the fact that they allow the child view to convey a preference to the parent view, but I find the name confusing personally. And what's really important is to understand that a preference key is a way to propagate data from a child view to a parent view without going through an explicit binding. And we'll see that the way to set up a preference key is actually kind of similar to how we set up an environment key. So let's go and create our preference key. So this time I just create a Swift file. I call it preference keys, like that. So we need to import SwiftUI because preference keys are defined in SwiftUI. And just like with our environment key, I'm going to create a preference key. So how am I going to name it? I'm going to give a very explicit name, so text field input, and then preference key. And this struct will need to conform to the protocol preference key. So that's why I was saying it's kind of similar to the environment, because we had environment key. This time we have preference key. Let's see what is inside this protocol. So once again, kind of similar to the environment key, we have a default value, and we have one more thing, which is a reduce function, and that reduce function will allow us to combine values as they are produced by child views, because you could imagine each child view producing a new value for the same preference keys. For the same preference key, you need a way to combine them, and it will depend of what you want to implement. A typical example is, imagine you want to implement a breadcrumb that is going to display where you are inside your app, in the header of your app. Then you would probably want to concatenate some strings, these kind of things. So let's conform to the protocol preference key. So first we need a default value. So here the value will be a string, and the default value will be just the empty string. And then we need the function reduce, which takes the current value and the closure to get the new value. And here I'm just going to say, okay, my current value, which is an in-out argument, so I can assign to it, I will simply make it have the value of the new value. So what this means is that as we go up the view hierarchy, we simply overwrite previous values for that preference key when a new value is provided by a view that is higher in the hierarchy. So we basically say we want to get the value for the preference key for the view, for the child view that is the closest to us. Just after, we will see another example where we will need to actually do something else than just ignoring values that are lower in the view hierarchy. All right, and so we have our preference key. That's all that we needed to do. Now we need a way for the child view to say, okay, I want to set a new value to my preference key. And to do that, we use the modifier preference. And you can see that it says that it sets a value for the given preference. Actually, it seems there is a default value for the preference key. That's interesting. I don't know what is the default value. But here, my key will be, so text input preference key, let me see, .self, because I want to pass the type. Okay, let me make a bit more room on the screen. And then for the value, it's going to be my text right here. It's not $text because it's not a binding, it's just the text. And when the text is updated, the body is recomputed, and so the preference is called with the new value, which is the new text. So this is how you inject, we could say, the preference key into the view hierarchy. So kind of similar to the modifier environment and environment object we saw before. And now we need to see how we retrieve the value in the parent view. And for that, in the parent view, we use the modifier on preference change. And so we pass our preference key once again as the key. And then we have a closure that will be called with the new value that has been passed through the preference key. And we need to do something with it. So here, for instance, I'm going to store it into an addState property. So it will be text input, which will be the empty string by default. And so I'm just going to set my text input to the new value. And finally, use it to display it. And if I've done things correctly, as my keyboard is with the wrong layout, but I can say something. Yeah, my keyboard doesn't have the right layout. It doesn't make it easy. Okay, and you can see that data has been passed from the child view to the parent view without going through an explicit binding. It was done through this preference key mechanism. The way I've shown it right here might feel like a bit like far-fetched, because you might be thinking, why don't I just use my my binding? I could just use a binding right here, and it would do the job much more easily. And that's true, but you would need to pass the binding to the initializer of the child view. And if there are several intermediary views behind them, you would also need to pass the binding through all of these views. And so that's why the preference key mechanism is useful. It's because it allows you to send values up the view hierarchy without having to provide a binding to all the initializers of all the views that are in the middle between the parent view and the child view. And if we even, like, let's imagine if I just put, like, I don't know, I put my child view into an H tag, for instance, we can see that it has no impact. It still works. Where is the W? It's there. It still works. So it doesn't matter how many intermediary views there are, the value is still being carried all the way up to the view hierarchy. Kind of similar to how navigation title was working. And we can probably infer that navigation title is implemented under the hood with a preference key. Why am I talking about navigation title again? It's because something that's interesting to see is that the syntax to deal with preference keys is quite verbose. So we need to define the preference key. Then we need to call the modifier preference by explicitly providing the key. In the parent view, we need to call on preference change by also explicitly providing the key. And most of the time, good practice, I would say, would be to create your own custom modifier to at least make it easier to do this part right here. So instead of doing dot preference with the key and the value, what I could do, so let me see, where I've defined my preference key, I could also do an extension on view, and I could say, how do I call my modifier? I will do something like text field input, for instance. So it's going to be text input, that's a string that I pass in as an argument. I just return some view, and inside on self, I call preference key, so like that. I pass in the value, and now I can rework how my child view works. Instead of calling the modifier preference, I call text field input, the modifier I have created. I still pass the same data, and normally my parent view should still work. Let's see. For some reason, the preview was not working. Okay, let's see. Does it still work? Yes, it still works. Like that. And so most of the time you would create this modifier, because in most cases, and I think we'll see it just after, what you would need is to implement a parent view that can consume state provided, values provided by its child views, but your parent view will be encapsulated, and it's the child views that will be unknown from your parent view. And so what you would do is that you would define the parent view and the preference key in your module. You would make the preference key private. You would only make the modifier public, and the body of your parent view would also be private because it would be in your module. And so people that use your code will only need to use your parent view and then the modifier on the child views to set the values that the parent view will consume. And I think it's what we're going to do just after. So it would be the good practice, because basically having to call preference and passing the preference key in the view, it feels a bit like low level boilerplatey. So encapsulating in a custom modifier like we did, personally, it's something I would recommend. I feel like it's a good practice. And so it's time we move on to the more complex example for the preference keys. That's why I wanted to do this simpler example before, because when I was about to start it, I was like, maybe this is a bit like a bit complex. Maybe we should go for something simpler first. So I'm going to go back to my login view, and I will actually make it be something that looks like a login view. So you can see I have written in French rather than in English. Reason is that it makes the length of the buttons be different, and we'll see that it's going to have an importance because I'm going to want to implement something linked to the width of the buttons with preference keys. First, let me add a bit of styling to my buttons. So something like that. Nope, I wanted to have this on each of the buttons. So actually, I will put my buttons into a group and then put that group into a VStack. Okay, much better. So I have my group, perfect. All right. So here we have my two buttons, and what I want to implement is a mechanism so that the two buttons have the same width, but not just a fixed width. I want the two buttons to take the width of the largest one of the two. And you can start to imagine how a preference key is going to come into play here, because what we need is a way for each of the buttons to report to a parent view what is their actual width. Then for that parent view to compute the max of the two width, and after that to get that information back to the two views to make each of them take the width that is the largest of the two. So let's see how we can implement it. I'm going to make sure I follow my script because, as you will see, it's a bit tricky, and you don't want to miss a step. Okay. So first thing we need to do is to create a preference key for that. So I'm going to go back to my preference keys file. I'm going to create a new preference key. I'm going to put it on top. So this time the preference key will be called the max width preference key. Okay. It needs to have a default value. So that default value will be a CG float because it's a width, and I'm going to give it a default value of 0, which kind of makes sense because if you imagine that the default value for a string is the empty string, then the default width needed to display that string is 0. So that default value, I feel, makes sense. After that, I need to implement my reduce function. And here it's gonna be a little bit different because we don't just want to set the latest value that we have received, because what's gonna happen is that we will have two child views, which are browser views in the view hierarchy, in the sense that they are at the same level in the view hierarchy. They come from the same parent. These two child views will provide a value through the same preference key, and so we need a way to let the parent know which value to use. As it turns out, it's quite easy here because we said we wanted to display the buttons with the width of the largest of the two buttons, and so we want to use a max here, a max between the value we already have and the next value that will be produced, and we store the result of that max. This makes it so that if one of the two child views says, okay, I need 10, and the other says I need 15, then we will set 15 to the value. That's all we need to do for the preference key. Actually, now we can start and use the preference key. So let me go into my login view for that. Where is my login view? I have too many views open. I'm going to close like a few of them. Okay. So I have my login view right here. Then I need a way for each button to report their size. So for this, I'm going to call a modifier. I'm going to call the modifier that allows me to get, let me see. I told you it would be complex, so I need to take a few seconds to see how I implement this. Okay, so it's going to look like that, and I'm just checking one thing. All right. So I need a way to know for each of the button what is their width. We've seen in the past on the chapter about the layout system that when we wanted to actually know the actual frame occupied by a view, we had a special view called geometry reader, which allowed us to do that. And so what we're going to do is that for each of the button, we are going to put in the background of each button a geometry reader. So like this. So the background modifier allows us to put a view in the background of another view, and that background view will be offered the same size than the view actually occupies. So that's why I'm using this modifier, and I put a geometry reader so as to be able to read the size occupied by each of my buttons. And so the geometry reader takes a geometry proxy as its argument, and we can use the geometry proxy to read the width and report it. And here the question is, on what do we actually call the modifier preference to report through the preference key? And the trick is to use a clear color. So a clear color is a color that is fully transparent, and by using it, it gives you like something, a hook on which you can call the modifier preference to set the value for the preference key. I wanted to highlight this because you might be thinking, oh, I could use empty view and then call the modifier on it. And while it would work at compile time, it wouldn't work at runtime because empty view is actually never rendered, and so modifiers attached to it are never applied. So it would be a bad idea to use empty view for this need. For that kind of need, the trick is to use the clear color, so a color that does basically nothing. It's a view that does nothing, and on it we can call the preference modifier. So we pass in our preference key. So it was max width preference key. I'm seeing I made a mistake when I name it. So I'm gonna use the refactor in Xcode to rename it and remove one of the extra n like that. Okay, perfect. And for the value, that's when I use my geometry proxy. So let's see. It seems like I forgot something. Yes, I actually expect Xcode to help me with some auto-completion, but it seems it's not the case. So we need to do it myself. So I get the width, and I get a build failure also. Let me see where it is. It's still here. Oh, okay. Seems to be better. Oh, because it's not default value, it's .self. That's why. Okay. Now the code builds, and so if this works as expected, this should provide the true value, the true width to the preference key. You know what? Actually, I'm curious to see if I print to the console. I would like to print something, but I'm not, or just put a breakpoint actually. We'll see. I'm not sure if it gets called actually if no one is listening to the preference key. Yeah, if no one listens to the preference key, it does nothing. Good thing actually to show you that, because it shows that there is like even if you implement something that are a bit like heavy on the computation side in a preference key, you can provide stuff to a preference key. If no one listens to it, it's not going to start any work that will not be consumed. So that's kind of nice. So we have set a way to provide value through the preference key. Now we need a way to actually read that value. So we will read that value at the level of our login view, so at the topmost view, so at the level of the vstack. So we're going to call on preference change. So I pass in my preference key, and then I will get a new value here. And what am I going to do with this new value? I'm gonna need to store it somewhere. So I'm gonna store it here, for instance, in a state property. So max width like that. Actually, here is just going to be a CG float. I'm gonna make it an optional CG float because the frame modifier accepts an optional CG float if I remember it, and so this way I have nil as a default value, which might be more correct than having 0. Saying I don't know what the max width is more correct than saying the max width should be 0. Here I just need to update with the new max width. Just need to be careful to use self here to distinguish the queue. Yeah, it did work. Okay, and we are almost there. I just need to actually use the preference key. And so for that, I'm going to call, so here on my group, I'm gonna call the modifier frame, and I will provide a max width, which is of type CG float optional, and it will be this max width right there. And this is the moment when we see, okay, something is wrong. I've made a mistake somewhere. We can see that they are both the same size, but it's probably not what I wanted to do. So let me see where I made my mistake. I think I might have called some things a little bit like too far in the view hierarchy, because yes, I think I need to call it okay, yes, I need to call it just, yeah, higher. Yes, that was it. So I need to call it higher before all of the extra formatting has been done. But what's nice is that, like, let me show it because I think I'm hiding it a bit, but it worked, because when I remove my modifier here, you can see that each button takes its intrinsic size to display. But when I add the modifier frame, now the two buttons take the same size, and it's being synchronized to use the size of the button that has the largest width. So here, for instance, if I make the first button twice as large, so it didn't update because sometimes you need to restart the preview. All right, this time it did update. You can see that now it's the first button that is driving the size of this group. And if I increase the size of the second button, and I just reshow the preview, then this time it's the second button that is back to driving the size of the group. So we were able to implement this syncing mechanism, so syncing the width of two child views of a same view. We saw that it's still like a bit more complex than what we had done before, because basically we had to pollute in a way our login view, because now our login view needs to know about the max width. It needs to know about updating the preference key. It needs to know also about reading values from the preference key. So just after that, we're going to encapsulate things to be a bit cleaner. But we were still able to achieve our goal, which was to have two child views of a same view, provide some data to their parent view, and then have the parent view execute some business logic on these different values. Here it was getting the maximum of them, and use that max value to make the two child views have the same width. Now let's see how we could encapsulate this a little bit better. I'm gonna want to create a new SwiftUI view, which I'm going to call syncing view. And inside this syncing view, I'm gonna want to basically encapsulate all of the logic to set the values to the preference key, to retrieve value from the preference key, to store it, etc., etc. So first, I'm going to get rid of the preview because it will simplify a few things. So this syncing view, actually, it won't do anything else than syncing the max width of its child views. So it will be a generic view because it will display a child view. So I'm going to create a generic type called content view, like this. And inside the body, so first I need a way to produce my content view. So for this, I need to have a closure content that is at view builder. This is similar to the closure we pass into a VStack, for instance. Okay, actually content view content might be even shorter. And so for the body of the view, I will just call the closure and return whatever it returned as the body. I'm gonna start using my syncing view into my login view. So let me go into my login view like that. So where would I use the syncing view? I would most likely use it in place of my VStack. So I'm going to use the syncing view right here, and inside of it, I will actually embed the content into a VStack. Okay, I'm going to pin this. All right, so it's still working, but it makes sense because I've just created a view that is basically a glorified VStack. Now I'm going to start moving some code into the syncing view. So what can I move inside the syncing view? First thing that's easy to move is the state, the max width, because that's the kind of the purpose of the syncing view, to manage this value and get it correctly and apply it correctly. So I'm moving it from the login view, and of course I need to also move the place where I was using it. So where was I using it? I was using it actually on my content, but not anywhere on my content. Remember, I really wanted to call it at a specific place in the modifier chain of my content. So if I call it here on content, content will be all of this. So it will be equivalent to calling the modifier here at the very end, which is not what I wanted, because remember, when I did that, it didn't work. So what I'm gonna need is create a custom modifier that will be able to call at the correct place. So let me create this modifier, and this modifier will actually be responsible for both setting the max width and also reading the value through the preference key. So for now, I'm just going to get rid of this code. I'm going to create my custom modifier. So I'm going to call it syncing width modifier. A custom modifier so has to implement the protocol view modifier, and you need to have a method that gives the body of the modifier. So how do you apply the modifier to some content which is a view? And here what I do is that I take my content. First, I apply the code to get the width. So with this code, I read the width of the content and I set it using my preference key. And then I put in the method to apply the max width. So just after, like that. And I've essentially taken this code here and moved it to my syncing view right there. So I'm going to remove the code from my login view, and instead I will be calling my modifier syncing width modifier. So I could call it like that, using the modifier that lets you apply a custom modifier, but it's not great at all. So what's kind of nice to do when you create a custom modifier is to also extend view so that you can provide a buffer method. So for instance, a modifier called sync width. We're going to need also a way to retrieve the max width from the syncing view. So for now, what we can do is simply store also a copy of the max width inside the modifier. And so here, the method sync width is going to take, what do I want to pass? I want to pass this thing, which is going to be, yes, I want to pass the max width, yes. Using max width, so like that. Here I have my CG float. And inside this method, which returns some view, I'm just going to call the modifier, this time using the syntax that is not that great, but that still does the job. So this one, and I pass in my max width. And what's nice is that this syntax, which is not that great, we only use it once in an encapsulated way, and then the rest of the time we'll just call sync width which will be much better. So we would do something like this, sync width using the max width. Now the issue is where do we actually get this max width? We're going to go back to it just after. Before that, I want to move the code to read the value from the preference keys. So I'm going to cut this code, and I'm going to move it also to my syncing views. So this time I'm going to apply it to the outmost view, so to the vstack right there. And the last problem I have is this max width, because this max width, I need to pass it somehow between the syncing view that reads and computes the correct value and the sync width modifier that uses it. And I don't really want to pass in a CG float because it lacks a little bit in encapsulation because it feels like the syncing view is leaking the data it's passing between the view and its modifier. And basically, if I have a float, there is nothing preventing users of my syncing view of modifying that value when I might not expect it or want it to be modified. And so the little trick here is to create an opaque type. So I create a struct. I call it syncView proxy. And inside of it, I'm going to store my max width. I'm going to declare it private. Here, I'm going to store, instead of the max width, I'm going to store a proxy. My default value will be just a proxy with the max width set to nil, like that. So here I can no longer do self.maxWidth. Instead, it's my proxy.maxWidth. And more importantly, my width modifier will no longer be using directly a CG float. It will rather be using a syncView proxy. Here I'm going to, of course, get the max width on the proxy. All right, I update this call site also. So I'm going to have the proxy, syncView proxy like that. I use the proxy right there. Okay. We can see that it is private, so I can't use it. No problem. I will just make it file private instead. This way, what's interesting is that syncView proxy will be accessible from anywhere, but the max width will only be available inside this file where I have both my syncing view and my custom modifier being defined. And so thanks to this little trick, now I can make it so that my content gets a syncView proxy as its argument. So in my login view, I use my syncView, I get my proxy as an argument. I can pass the proxy to the modifier that works along the syncing view. But if I try to see what is inside the proxy, there is nothing visible because everything is file private. So the proxy is just an opaque object here. And this allows me to have a nice level of encapsulation. And if I resume my code, you can see that it's still working, and what's better is that now the login view feels much less of a mess than what it was a few minutes ago, because all the traces of using preference keys have been encapsulated away inside the syncing view. And now I just need to use my syncing view, and on the group of views for which I want to sync the width, I can do that, and to make the link between the data that was not received, that was fetched by the syncing view and that was computed so as to have the correct width, and the modifier that will actually apply that width, I use my proxy object, which is an opaque object. So like I was saying, this second example is a bit more complex. I guess now you understand why I wanted to go with a simpler example first. But I feel like it's still a good example because it shows you a kind of a real world use case of when to use preference keys to get data from two child views at the same level in the view hierarchy and compute that data in a way that we can synchronize the behavior of the two views. So I find this example quite nice, especially because it highlights the fact that whenever you want to use preference keys, you probably want to encapsulate that either in custom modifiers or in custom views, because you don't want to have preference keys laying around in the code of your views. It adds a lot of verbosity, and basically it kind of makes your view a mess, and your view is no longer just about what it displays, but about also how it displays it, and it's just so much better to encapsulate this in modifiers and custom views, and custom modifiers. Let me see, I think I've actually shown you everything I wanted to see you. So it's kind of ironic that one of the chapters I find the most complex is also one of the shortest one. But the reason why it's short is because I took a lot of time to talk about the basics of state management and of data flows. So when we reach the topic of more complex data flows, it's easier to explain it. But what should you take away from this chapter? Basically, that when you want to make two views communicate without providing explicit data flows through the initializer through a binding, you have two possibilities. If the communication is from the parent to the child view, then you have to use the environment. And if the communication is from child views to a parent view, you use preference keys, which are a bit of a misnomer. And these two mechanisms are quite similar in how they work, in the sense that you create environment keys or preference keys, and using these keys, you are able to inject values, either inject values in the parent that the child will be able to get, or inject values in the child that a parent will be able to get. What's nice is that these two mechanisms are very implicit and kind of like a plug and play, in the sense that a parent can inject values, and if no child ever reads it, it's no problem. We've seen also that a child can send values, and if no parent ever read it, it's also not that much of a problem, because most of the heavy computational work will never get executed anyway. And now that you know these two mechanisms, what's interesting is that when you use the built-in modifiers, you can start to think like, oh yes, for instance, when I set a foreground color on a view, and all of the child views get that foreground color, it's probably because it uses the environment under the hood. And same way, when you use the navigation title, or also when you use here at the app level, you use the tab view modifier, and the parent view is able to display the tab view, even though tab view has been defined into a child view. It's probably because tab view is also implemented with a preference key under the hood. So it's kind of like satisfactory that you're able to be like, oh, okay, this built-in modifier now I know how it is implemented. I see Vlad and Hubertian, you're saying nice, great examples and explanation. Thank you. That's really nice to read, because this chapter is quite heavy, and as I go into the explanation, there is always the feeling of like, am I making some sense or not? So I'm glad to hear that you've enjoyed this chapter, which was a bit theoretical, we could say, not as practical as the previous chapter that was about navigation, but still. I feel like it's one of the, all of the chapters are important because they all cover one of the basics part of SwiftUI, but this chapter is one of the chapters you could be thinking, okay, in a training course to discover SwiftUI, should you talk about it or not? I feel like it's very important to talk about it, because without this mechanism, you lose a lot of the flexibility of SwiftUI, so it's very important to know about it and to leverage it. to tell you my personal feedback, environment values are super useful, and I've used it a ton of time at work to inject values or closures through the environment, especially when I put, like I said a bit before, SwiftUI views in a UIKit app. Preference keys, you don't use them as often. Honestly, I don't have an example of when I used a preference key that jumps to mind, so I guess it goes to say that you don't use it that much, but it kind of makes sense because you tend to use preference keys when you are creating complex parent views. And most of the time, these views, they are already provided to you by SwiftUI. You will be using navigation view, you will be using a tab view. So if you start to make your own framework of custom UI components, then there is a good chance that you will need to use preference keys at some point. But if you find that you don't use preference keys that much, honestly, don't get alarmed, because when I think about it, I don't use them that much at work, and there is no problem. So it's a mechanism that is a little bit less common when you're writing app code. A bit more useful when you're writing framework code, but when you're writing app code, it's a little less common, but still, it's very cool to know about it, because the day you need it, you want to know about it. Otherwise, you will end up like passing a lot of bindings for a lot of initializers, and that's probably not what you want. So that's basically all for this chapter. So what will next chapter be about? Next chapter, I think it will be the penultimate chapter of this training course, and we will touch on the last big topic that I haven't talked about at all for now, which is how do you interoperate between SwiftUI and UIKit. So how do you put a UIKit view in a SwiftUI view hierarchy, and how do you put a SwiftUI view in a UIKit view hierarchy. We'll see that it's pretty well made, and it's quite easy to do. But that will be for the next chapter, or for next week for the people who are watching live. It's the end of this chapter, so thanks a lot for following it. Thank you for the nice messages in the chat while I was recording this chapter live. And I guess I just have to say, have a good rest of your evening, of your day. And thanks for watching, and see you next time. Bye bye.